Alright, for our first vibrations project, we have myself, Connor Denton, Drew Falk over here, and we also have Ethan Anderson videoing for us right now. So what we're going to do is we have a system where we have a tire imbalance. Our CG is located off of our center line, and then our mass element here would be the wheel, and our spring element is our axle spring, and we also have a damping element, which in this system is a shock absorber. And this type of system can be encountered everywhere in cars and trucks, all kind of vehicles. So I'll let Drew take it from here.
All right. And here we have a drawing of the system. As you can see, our center of gravity is off-center with the center line of the wheel. So what this does is it creates an imbalance with the inertia of the wheel, which will cause this to go up and down and vibrate. And in turn, it will cause this spring and dampener to compress and to be in compression and tension, and it will create vibrations in this X direction. And this is also elevated above the ground on a jack, so this isn't coming in contact with the ground. So I'll hand it over to Ethan to talk about the equivalencies.
So how do we get this into a simplified form? And basically this is how you can set it up, where it's pretty simple. You have your spring here, and your shock absorber is usually inside the spring. You can see this on a lot of vehicles. Here's your shock absorber, here's your spring, and then here's the mass equivalent, where you have just a little bit of mass that's off center. So, and your X direction, where you have your translation. So then, to put it in the graph, this is how your vibration, this is your vibration here, where you got the spring force. I guess that could be spring in your force on your shock absorber anyway. So as the wheel is rotating up into the spring where it's compressing it, and then down as the wheel keeps rotating, and so you have that vibration that you can feel in your steering wheel, and very bad vibrations in that case.
And this is a forced system vibration from that.
Yes.
From that irregularity.
It's forced vibration because your center of gravity is off of center. If that center of gravity was on your center line, then you wouldn't have any oscillating force on your shocks.